All right, here's the homework part of day 3. So you've already filled out x-intercept, y-intercept, and I said those backwards, but you get the gist. Maximum, minimum, domain, and range. So today we're going after increasing, decreasing, rate of change. Okay? Plus, we've got these extra rate of change problems that we'll be doing as well. Okay? So, let's get going. So we're using interval notation for increasing and decreasing. Rate of change ends up being a fraction. Okay? If you're new to this, on interval notation, go watch the other 2 videos on increasing and decreasing the notes, as well as domain and range the notes. You'll get a much better, more in-depth explanation of intervals. Okay? So we're just going to get right into it. We're going to start with doing increasing and decreasing on everything first. Then I'm going to come back and do rate of change because they're so different. I like doing it that way. You may not. You may be fine doing it however you want to in class. That's great. This is how I'm doing it. So increasing and decreasing. We're always looking left to right. Okay? Increasing going up. Decreasing going down. And we use the x values. I don't care how high up it goes or how far down it goes. I'm using the x values for the intervals. So we start here at -4, and I'm increasing till I hit 0. So from -4 to 0, that's where my graph is increasing. Then I start at 0, and I'm decreasing till I get down to 5. So the x value of 5, so from 0 to 5, that's where I'm decreasing. Okay? And that's all there is to it. Remember, we're using the interval notation using the x-intercepts. Furthest left x, furthest right x. Furthest left, furthest right for each piece. Okay? All right, now we look at this one. So this one's kind of just the opposite. All right, we start right here at -6, and we're decreasing till we hit -2. So from -6 to -2, I'm decreasing. Then increasing, we start here at -2, right? And we're increasing till we hit +6. Okay, so from -2 to +6, that's where we're increasing. All right, now 5, okay, we've got a little difference. So starting here at -0.5, we're increasing till we hit that value of 0. Okay, so to 0. Then we notice we're decreasing. From 0, we go down till we hit 1. So from 0 till we hit 1, we're now decreasing, 0 to 1. Then we start increasing again. So because we had to jump, we put the little u there. So starting at 1, I increase till I get to 1.5. So from 1 to 1.5, we're increasing again. Remember that little u here stands for that space that we jumped when we were going down. Okay? But remember, we're only focused on these intervals. That's what these brackets are telling me. I don't care how high up we went or how low. Okay? I don't care about from here to here how it's changing. So, there we go. Speaking of, I don't care about that. I think this interval is wrong. Okay? This should be from 0 to 1. I think I got caught up in the y values, not the x values. All right, now this one we have a few things happening, right? So we start out by decreasing. So from the x value of 0, we decrease till we hit right there. So that's the start of our decreasing interval. So from 0 to 3. Now I notice I'm going to decrease again, okay? So I can hit that union. If I really wanted to, I could even just go and say. Okay, so from 10 to 13, I'm decreasing again. Okay, you don't have to do it in order. Then I start down here and I'm increasing, and I stop. Or do I? I don't. I'm increasing. It's at a different rate. But do I care? No. So I'm increasing in the middle section of it. So from 3 to 10, I'm increasing. Okay? And it works just like that. All right. now with the tables, a little different. Okay, we go from one y value to the next to see if we're increasing or decreasing. -5 to 0, I'm increasing. 0 to 2, increase. 2 to 3, increase. 3 to 5, increase. 5 to 4, decrease. 4 to 2, decrease. But it's still, again, it's the x values. So for increasing, we started at -2, and it increases till we get to 2. Then it stops increasing. And so at 2, we start decreasing till we get to 4. So from 2 to 4, and from -2 to 2. Okay, so those are kind of confusing, but that's how it goes. So 20 to 15, decreasing. 15 to 10, decrease, decrease, decrease. Now I'm increasing again. So we increase from 2 to 6. And we're decreasing from -6 to 2. Okay, because we use those y values to tell. And if you need to, by all means, plot these points, draw the graph, get a better handle on it. Okay, 100 to 50, going down, going down, going down, going down, and it jumps back up, and then it goes back down. So I'm decreasing from -3 to 5, actually to 2, huh? Got to be careful of that. So -3 to 2, then I'm increasing from 2 to 5, then again I'm decreasing from 5 to 6. So do the little jump, 5 to 6, we're decreasing. All right. Okay. Now on 12, so we take a look at this. So I'm increasing 0 to 3, 3 to 9, and it looks like I'm increasing the whole way. So decreasing, never, so we do the empty set, or we hit never, or we put no or none, any of those work. So we start at 0, increasing, and we keep increasing till we get to 6. We like those ones, a lot easier to deal with, right? Okay, let's take a look at rate of change. So we've got some extra tables here. So rate of change from 3 to 10. Remember, with rate of change, it's rise over run, the vertical over the horizontal. Okay, the interval is the horizontal. So if I take the second number, 10, subtract the first number, 3, that's going to give me the run. 10 minus 3 is 7. So my bottom number is 7. Then I find the y values and do the same thing. So at 3, we had a y value of 58.32. At 10, 27.89. So if I go 27.89 minus 58.32, that'll be my top number, okay? And I do them in the same order that I did the x values, okay? So I would go 27.89 minus 58.32. You've got a calculator, and you get -30.43. Anytime we have decimals, just take the decimal and divide it, and let's get the overall decimal. So I'd get -4.34714, and we could round it off at maybe the nearest hundredth. So -4.347. There's our rate of change. Okay, on number 12, because now we're working our way backwards with rate of change. Okay, my rate of change is from 2 to 5. So from 2 to 5. So 5 minus 2 gives me my horizontal, which is 3. Okay, so would be 3. Then I'm going to go 243 minus 9 to get my vertical, which I probably should know how to do this in my head, because I'm holding a calculator, I rely on it. 234. So 234. If I wanted to, I could divide that by 3, and it actually comes out to 78. Really nice number. Nice. Remember, rate of change, if I were to change different ones, isn't always the same. Okay, that would be 27 over 3, which would be 9. Okay, so they can be vastly different depending on where in the interval we're doing it. All right, so let's take a look at this one. So negative 3 to negative 2. So negative 2 minus negative 3, it's like plus, gives me a positive 1. Okay, so then negative 2 is 50, minus negative 3 is 100. So 50 minus 100 is negative 50, so negative 50 over 1, or just negative 50. So that rate of change is going down by 50. All right, we've got another one table here. So 120 to 60, so I go 120 minus 60, gives me 60, so on the bottom it's 60. So at 60, we have 131. 120, we have 152. You don't need the decimal places there. So if I go 152 minus 31, that should be 21, right? Yep, 21. So I get 21 over 60, which I could leave that way. If we wanted to, we could, divide it by 3 and get 7 over 20, or I could even make the decimal 0.35. Either one of those would work, and depending on what we're trying to get out of this, that would determine what we would want to happen. So, number 8, interval of negative 6 to 6. 6 minus negative 6 becomes positive 12, not 0, because it's minus a negative. Negative 6 is 20, positive 6 is 4. 4 minus 20 gives us negative 16, so rate of change, negative 16 over 12. Which could reduce to negative 4 over 3 or negative 1 point something, negative 1.3. All right, number 7. Okay, I said that this interval was bad, so we're actually doing it from, it was the graph that was bad, wasn't it? So negative 2 to positive 2. So 2 minus a negative 2, that's like plus, that gives us 4. So for the bottom fraction is 4. For the top, negative 2 is negative 5. Positive 2 is positive 5. So add that and we get 10. So we get 10 over 4, which we could reduce by 2's to 5 over 2 or even 2.5. Okay, fine with any one of those. All right, here's the one that we had to do from 0 to 1. Clear me some space. So I go 1 minus 0, which is 1. So at 0, we're up here at positive 2, and at 1, we're down here at negative 2. So there's two ways I could do it. I could keep doing it the same way and say at 1, we are negative 2, and at 0, we are positive 2. Negative 2 minus 2 is negative 4. And I'd end up with my slope of negative 4 over 1, or just negative 4. Or I could count. 1, 2, 3, 4. Went down, it's negative. 1, 2, to the right, it's positive. Oh wait, that's 0.5, isn't it? So 1. And we get the same exact thing. So with graphing, there's two ways we can do it, right? Okay, again, I'll show you both ways. So 6 and negative 6, so 6 minus negative 6 would give me positive 12, right? For my bottom number, my denominator. Then at 6, we're right up here at 10. So we'd have 10 minus, and at negative 6, where did that come from? That is incorrect, because we don't even have a negative 6, do we? Obviously, I didn't pay attention on some of these intervals. So we'll just fix it. We'll say from 0 to 6. Okay, so we'd go 6 minus 0, which is 6. Then at 6, we're up to 10. At 0, we're up to 10. So 10 minus 10 is 0. 0 over 6 reduces just to 0. Okay, which if I just graphed it, notice it's a horizontal line. Horizontal lines always have a slope of 0. All right, last two. Let's hope we got these intervals right. So negative 2 to 0. So negative 2 is right here. 0 is right here. So we go up 2 to the right 2. So 2 over 2, which would be 1. If we did it the other way, it would come out to the same exact thing. Okay. Number 2, interval of negative 6 and 2. So 2 minus negative 6 gives us positive 8. At 2, we're up to 1. At 6, we're up to 5. 1 minus 5 would be, something's not adding up in my brain here of what I did. Oh, negative 6, duh. That's what's throwing me off. So negative 6 would be right here at 1. So that'd be 0. So 0 over 8 again. Once again, we get that horizontal line. So it's 0. Now if we look at 3 and 4, okay, using the equations, remember, we go like this. So 10 minus 1, so negative 9. Then we have to figure out what f of 1 is and what f of 10 is. So 3 times 10 minus 4. 3 times 10 is 30, minus 4 is 26. So f of 10 equals 26. So we have 26 here. F of 1 would be 3 times 1 minus 4. 3 times 1 is 3 minus 4 is negative 1. So f of 1 is negative 1. So minus negative 1. So that'd be plus. So we'd get 27. Right? Oh, and that's a positive 9. So we'd go 27 over 9, which would be 3, which, because it's linear, same as our slope right there. Now number 4, not so easy because we can tell it's exponential. So I go 5 minus 2 to give me 3 for the bottom. Okay, then I go f of 2, so 4 times 3 squared. 3 squared is 9, 4 times 9 is 36. So f of 2 equals 36. So I've got minus 36 here. And then we do it for 5. So f of 5 equals 4 times 3 to the 5th. 3 to the 5th, that's 3 times 3 times 3 times 3 times 3. 9, 27, 81, 243. 4 times 243. I'm going to use a calculator for that one. Get 972. So f of 5 equals 972. So 972 over 3, which comes out to be 324 for our rate of change. Big rate of change, but exponentials do that. Okay, so that's pretty much it with this one. So that one took us a little bit longer. So you probably didn't get it done in class, but you could have taken it home and finished it, and hopefully watch that to help you get your stuff done. All right.